Cool. Guys, good morning. Welcome to day 2 of DataCon LA. My name is Courtney Fowler. I'll be your host today, and I'm joined by my co-host, Mirali. Today, I'll be moderating chat and Q&A during the session, and today we have our guest, Raj Hedgpeth with MariaDB. He'll be talking about, today, our session's title is Columnar Storage in Python, Powering Modern Databases. So a little bit of background about Rob. Rob, this actually in this session we'll be examining how distributed columnar databases are power real-time analytics in modern database science. We will also take a closer look at the MariaDB ColumnStore storage engine architecture, exploring how it can be combined with Python to create robust solutions to modern-day data science analytical problems. So, without further ado, we'll go ahead and introduce Rob. Rob, take it away.
Awesome. Thanks, Courtney. And hello, everyone. Thanks for joining us on this Saturday. I hope you're having a really good time at the conference. I know there's been a really good amount of talk so far, some really good ones. And I hope that you're enjoying it so far and can enjoy it afterwards. I hope I don't disrupt that enjoyment during this. But today we're going to go over columnar storage and then getting a high-level look at columnar storage, what that looks like from an architectural perspective, why you'd even really want to use something stored in a columnar format. And then we're going to take a more pragmatic look, right? Taking a look at how we can actually dive in and use a columnar-based storage engine with Python, and then a couple of other tools like Jupyter Lab, pandas that we can use for data analysis and kind of bringing together our data structures, but then be able to then visualize something in real time using something called Plotly, right, which is just a visualization library. But we'll get into all of that here in a bit. Okay, so first things first, my name is Rob, as Courtney said. I work on the developer relations team at MariaDB. So simply put, I try to do everything I can to just improve the journey of developers using MariaDB products and capabilities, right? So everything from providing demonstrations to creating blog content, video content, in order to just really help that journey and help developers be able to use the products. And then on the flip side of that, if you happen to have any questions or any feedback either about this session or in general as we get into ColumnStore and columnar storage with MariaDB, I then take that feedback and try to do my best to relay that into product and engineering so that we can make the products better. After this session, if you've thought of some more questions or maybe just want to ask me something else, you can hit me up on my email at robh@mariadb.com. You can follow me on Twitter, probably real Rob, or after you've seen some of my code, you may be so inclined as to go judge the rest of it. And you can do that at GitHub at Hedgpeth. All right, so let's go ahead and dive in here. We're going to talk about columnar storage. And I know that a lot of times at conferences, people come in from diverse backgrounds, right? You want to see a session that maybe you've never even looked at that topic. Maybe you have seen this topic, but you want to look at the demonstration and get a more pragmatic view. I know there's a lot of people coming from a lot of places. So we're first going to take a look at kind of the high level stuff of what it is, right? What it means most simply. And then we're going to get everybody on the same page, and then we're going to dive more into the architecture. And then of course, we'll all be running at the same pace as we jump into the demonstration. And hopefully everybody will get something out of it at that point. But from what it is, right? Well, you likely know how tabular data is structured, right? So you think about a typical relational database, and being able to store using rows and columns. But ultimately, what you may not know is that data, when it's stored, like physically stored on disk, it's actually stored from a tables perspective, right? Inside of what is likely multiple files, right? And there's a lot more to it, but this is a very simplistic view from a high level of what that looks like. On the right-hand side, it sounds just like what we think it sounds like, right? To store something from a column perspective, you're actually splitting up the data itself and then storing those on individual file or most likely multiple files per column. And there's a lot of reasons that you would want to do this. And of course, there's a lot more depth that we'll get into of what this means. But why you'd want to use it, and I'm not really big on bullet points, so I'll try to cruise through these here quickly. But there's a lot of benefits. And I figured that this really justified a bullet list page, right, that we could look at. Well, one, a lot of data warehousing is done using columnar format. It provides a lot of benefits like high compression. And underneath this, what I'm going to be indicating are things that we at MariaDB have for ColumnStore, and we tout as features within Columnar storage. Now, that's not to advertise MariaDB over other Columnar storage products. It's just that I don't want to go out of place or speak out of turn saying that all of these features exist in every single Columnar solution. That's certainly not the case, and there's certainly other features even that exist probably in other Columnar solutions that may not necessarily exist in MariaDB, but this is really the high points of what we really get out of it, right? So as we look past just simple data warehousing and some of this compression that you get, and we'll certainly dive into why that's possible later, you get this idea of real-time, or the ability to use real-time or operational analytics. And what that means is that you can write queries in real time on massive amounts of data. And that's really something that is more necessary today, of course, than it was 5, 10, 15 years ago, as we look at applications that want to capitalize on historical or analytical information within operational applications. And certainly you can do that using columnar storage. And we'll get a little bit more into how you can combine those as we go throughout these slides. Of course, you'll have the ability to have great handling of sparse columns, the ability to handle a large variety of columns, or, a large amount. And then we'll dive a little bit into how the storage itself is distributed, right? So rather than it being just completely replicated all over the place and held in a monolith as a primary, and then maybe you got your replicas, it's actually a distributed storage engine, which is going to allow you then to partition data across multiple different instances. And then that in turn allows you to scale out pretty large, right? So handling large amounts of information. And then underneath the hood, from a use or processing perspective, then you get a high level of concurrency because of the way that it's architected in a distributed system. And then last, but certainly not least, and it kind of relates to that top real-time analytics portion, is that you don't have to add indexes, or what you think of as performance enhancing indexes, to get what you want to out of really snappy, really performant queries on massive amounts of information. And we'll see that in the demonstration itself. And to kind of put this back to the graphical view that I showed before, how you can think of that in your head, and I like to mix code and visuals to kind of help get everybody looking at this the same way, is that if we think of simple select statement, and something where we want to do an aggregation. In this case, we've got maybe 9 columns, maybe more on this table, but we want to do an aggregation or an average on column 9 for the table, right? We're not adding anything else. It's a pretty simple query in this point. But here on the left-hand side, the way that we can really start to see the advantages of columnar storage, or storing things in a columnar format, is that on the row-based side, as I mentioned before, things are stored from a table perspective. So whenever you go to run a query like this aggregate query, what's going to happen is that if every row is 200 bytes, which is going to have to look at the whole row in order to be able to get the specific column that it needs, that information, in order to do the average, and it's going to have to look at the entire table in this instance, right? Because I haven't put any kind of filter. What that means theoretically is that if every row is 200 bytes, then on 1 billion rows, then you're looking at about 200 gigs of disk I/O used. On the other hand, if you look at a column-based approach, because everything is stored in a column on those files and ultimately able to get at just that column information rather than having to look at the row, then you're looking at whatever the byte cost is per value of that column. So in this case, if theoretically it's 4 bytes on that same 1 billion rows, then you're only looking at 4 gigs of disk I/O. And that is really the foundation of what starts to make this pretty eye-catching, pretty awesome feature that we can see that we get a lot of performance benefit as. But we're going to dive a little bit deeper on what that means and architecturally how that's set up as we get into this. And we're going to specifically, of course, look at column-based storage. But first, I like to kind of set this up as, for those of you that may not necessarily be familiar with MariaDB or even the MySQL ecosystem, you may not understand that it's really built off of this idea of using pluggable storage engines, right? So rather than swapping out the entire system to use something like Columnar format or maybe more of an operational database or distributed SQL, that environment, MySQL, MariaDB, actually use pluggable storage engines. Now, this isn't to advertise. This is really mainly to kind of set up in your minds what this looked like. So when we get into the demonstration, you can get a better understanding of how this is being used. And while I mean, using entire systems, by that I mean that, typically or traditionally, if you wanted to use different types of data models or data structures in order to store your data and access your data, you're going to use more specialized databases, right? You're going to use an RDBMS, you're going to use NoSQL, maybe for something write intensive. Maybe you'll use NewSQL for distributed or scalable types of solutions, and then more of a columnar format if you want to look at something from an analytical perspective or maybe data warehousing or something. But in a pluggable storage solution or a pluggable storage format, what it means is that the storage itself can just quite literally be plugged in or taken out to provide those same types of storage mechanisms or data structures that you would use within your solutions and applications. And the benefit here is that one, it's all in one database, right? The other thing is that you get the ability to use the structured query language for everything. So rather your workload is mixed or write intensive, or you want something more scalable for OLTP, or maybe you want, big analytics and the ability to write really snappy queries on that, you can use that all just using SQL. What this looks like from a storage engine or more of a, a data architecture perspective is that they use different approaches, right? Whether it be a B tree or a log structure merge tree, distributed SQL or Columnar, as I mentioned before, to be able to do that. And more specifically, as we get to look at MariaDB, we have named storage engines that accomplish these things. So for MariaDB specifically, we have something called InnoDB, which could handle more of your mixed workloads for kind of your traditional OLTP applications. You can use MyRock, something that is more write intensive. Maybe you've got an IoT application that you want to be able to use to expand, which is a new storage engine from MariaDB that allows distributed SQL. So you can think of something like Yugabyte or Cockroach, right? That allows you to have massive amounts of information, transactional information, and be able to scale, theoretically infinitely with that data itself. And then lastly, of course, the topic of this conversation is ColumnStore, which is a MariaDB storage engine that stores data in a columnar format, and then is going to allow us to be able to do things like data warehousing, or even take a look at operational or real-time analytics on our data, all using SQL or the structured query language. All right, so that's the gist of it. Now, from an overall, as we kind of span out from a more practical standpoint, what this means is that not only can you set up these pluggable storage engines in individual database instances, you can actually do this on a per table basis, right? So you can target pluggable, the pluggable storage engines for maybe you have an InnoDB situation. In this case, we're looking at an e-commerce. It's just a mock application, looking at an e-commerce database that, if you think about e-commerce, it's got quite a variety of workloads, right? From everything from being able to view and, maybe even, write some data with a product catalog, to then being able to have purchases, which of course are very write intensive. Maybe you want to use something like MyRocks for that, to shopping carts where, customers can kind of laissez-faire come in, they can create a shopping cart, they don't necessarily have to close it out. And so you might have this massive scale just depending on the customers that you have. For that, you could use something like Expand, and you can create tables for each of these. And then lastly, if you want to track something like clickstream data, right? A massive amount of information. It's not necessarily the transactional type that you get from the distributed. It's more that you're wanting to analyze that, right? So you want to look at the analytics of clickstream data. You could possibly store that inside of ColumnStore. Now, that's not to say that you would structure a database this way, but it kind of gives you a little bit context to the idea of pluggable storage engines with MariaDB. And of course, if you wanted to use MySQL as well, they've got different pluggable storage engines there as well. Now, taking a closer look at MariaDB ColumnStore, and really this is to set up, once we get into the demonstration, in the back of our heads, kind of knowing what's going on as we look at the more pragmatic view, we're going to take a look at first the storage architecture from high level to get an understanding of, it's one thing to say, hey, we store things in a column format, and it stores those, in individual files or multiple files. Well, what does that mean, right? And, You know, why is that faster? And, you know, what is happening underneath the hood in order to make that happen? Well, we're going to dive into just that, again, from a higher level, because this is a pretty deep topic. So there's certainly, you know, more layers that you could pull back, and you could go a lot deeper into the particular algorithms used for certain things. But we're just going to look at it from a higher level architectural approach, and then be able to then, you know, slide into the demo pretty easily. So first things first, as I mentioned before, you know, you have the ability with your standard operational, or kind of more what you think of as your transactional database, like your typical relational database. On the left-hand side, if you wanted to do that aggregation, that same select average of column 9, it's going to look at the whole table, and again, possibly, you know, be able to take up a large amount of disk I/O in order to be able to accomplish that. Now, what I want to point out here is that the MariaDB database instance itself, right, contains InnoDB, again, that pluggable storage engine, and it's going to communicate directly to disk, you know, the physical disk, and store the data and handle all that, you know, back and forth directly. With ColumnStore, it actually has an interface, right? And that interface exists within inside a MariaDB server, or the server instance, that you would typically think about. It's going to take the parsed SQL, right? So the parsed SQL is going to come in to ColumnStore interface, and then the interface then is going to be responsible for creating executable processes that it then sends to the ColumnStore process, or, as we'll see a little bit later on, multiple ColumnStore processes which are distributed within different database instances, right? You can be theoretically infinitely distributed in order to be able to take a look at distributed data for your columnar format. And then the ColumnStore process itself then is responsible for communicating and doing all the operations with the actual physical disk at this point. Okay, so diving into that ColumnStore process and its communication with how it actually communicates with the I/O, right? So actually storing the information, we're going to look at something called extent mapping. And let me look at time, just make sure I'm moving along here. Extent mapping is something where we're going to first decide how we actually segment, right? So how we actually store the information, and then that's going to provide us the ability to create different kinds of approaches, or what we'll see as extent, the actual mapping part, approaches for being able to, you know, isolate and kind of nail down the data that we want. And that all starts really with this idea of a partition. And you can think of a partition as being the entire column itself, right? So it's all the data, say before I had column 1, column 2, it's all that data, right? Column 1 as a partition. Now, if you've got a ton of information, right? Just a ton, like, you know, millions or maybe billions of records, then what's going to happen to that partition is then it's going to be segmented into files. And these files then are split up into these more logical groupings of 8 million rows or 8 million records called extents. And then extents themselves can be split up into smaller portions called blocks. And the number of blocks is going to be indicative on just how large the column data type is, right? Or how large the column is. So if you've got, you know, something like a 1 byte column value, or, you know, column block, column ability to store that, then you're going to have fewer blocks, right? As you have, you know, stacked in those 1 byte data segments. On the other hand, if you've got something that's 8 bytes, right? So you've got some, you know, data type to take in 8 bytes, then you're going to have more blocks. And that's really all you need to know from this highest level. Of course, it gets a lot deeper than that. But what we specifically want to look at here is this idea of extents. And as I keyed in on the top here, extent mapping. And what that means is that let's consider and this is a purely hypothetical situation, right? A pretty basic one. As you look at my very creative naming with column 1, column 2, extent 1, extent 2. But what we want to gain from this is an understanding of how extent mapping utilizes the ability to really pinpoint what we don't want to look at in order to be able to query and get the information that we do. And that'll make more sense as we start to look at it. But let's consider this query, right, where we're trying to select from something called my table, and we're looking for column 1 and its value. In this case, we're just assuming that it's some kind of integer to keep things simple. And we need that column 1's value to be between 220 and 250. Now, on the right-hand side, we can see that these extents, again, are the logical groupings of 8 million records. What that's going to mean is that we've got, all of these different rows that may have different values, right? And we can see our min and our max. And we've just split this up hypothetically in that extent 1, 8 million contains, 1 to 100, and then we've got 101 to 200, 200, 300, and so on and so forth. So if we're looking for column 1 between 220 and 250, we know that we can automatically then, because we have the information on these extents, be able to eliminate extent 1 as a logical grouping of data, extent 2 and extent 4. And this means that when we find the information, then of course it's going to be in extent 3 somewhere. So we've pushed off all the rest of these, 24 million records that we didn't have to look at, or potentially 24 million records, and only having to look at 8. So that helps us from a performance perspective be able to pinpoint exactly what we have to query against. So we're querying against less values or less data essentially at that point. Now, if we wanted to make this a little bit more complex, and then spanning that 2 columns, and imagine that these 2 columns, of course, exist in the same table, indicating the same rows, and we can see that, of course, we first have indicated that we want column 1 between 220 and 250, but now we're also saying that we also want column 2 to be less than 10,000. Well, if we do this, then what's going to happen is that extents 1, 2, and 4 have been eliminated from column 1 as viable candidates to receive that data, and then extents 2, 3, and 4 have been eliminated from column 2. So we actually don't return any information because of extent mapping, and it very quickly allows us to do this because of extent mapping. All right, so next, from that perspective and extent mapping, that provides us just part of the piece to the puzzle, being able to improve performance and be able to very quickly be able to query against large amounts of data in real time or operationally in kind of a dynamic fashion. But what about the distributed portion that I mentioned before? What does that mean, right? And why would we want to do this? Well, if you think about databases in general, right, there's a lot of value to just distributing them. You get the ability to scale, right? Scalability is a pretty large reason to have distributed systems. Availability and the ability to stay up running and be able to use that is another one. But from a scalability perspective, what this means is that you may start with one instance, or what you could think of as a node for ColumnStore, and then be able to add that on, whether it's a server, on-prem, whether you've got some kind of VM, whether you're running this in a container, you can spin these things up as individual instances. And that's going to allow you to be able to, again, utilize the ColumnStore interface, right, which is then taking the parse SQL, and it's relaying that, as I mentioned before, to every single, it has the ability then to speak to every single one of the ColumnStore processes. And this is important to point out because by nature, when we look at this isn't a replicated environment. This means that the data itself has been distributed, right? So chunks of data have been distributed into each one of these as we see the disk below. So what happens here is that the interface, the ColumnStore interface, not only has the ability to talk to every single ColumnStore process. In fact, every ColumnStore instance has the ability to talk to every other instance, making it distributed. But from a processing perspective, this isn't done, just synchronously. This is all done asynchronously, or this is all done in parallel to one another in order to be able to return these. So that makes it a lot faster. And if you think about increasing the amount of cores, or basically just the horsepower of the machines, the resources that you're using this on, you have the ability then to run multiple different threads and run multiple different processes all at the same time or in parallel in order to be able to look up this information and ultimately capitalize on the ColumnStore processes that exist in each individual MariaDB ColumnStore instance. So that is the gist, right? And that's a lot, but it certainly gets deeper than that. But that is really all you need to know in order to be able to get into utilizing ColumnStore, and probably maybe a little bit more than what you actually need to know. But it provides a good amount of background so that when we jump into it, it'll make a lot more sense. So I'm going to go ahead and jump into a demonstration where we're going to take a look at how we can use ColumnStore, MariaDB ColumnStore engine, and I'm going to be using that from the cloud. And more specifically, I'm going to be using it in something called MariaDB SkySQL, which is MariaDB's own, homegrown database as a service. And it's just a managed database which allows you to spin up different kinds of services for transactions, or in this case, we're going to be using an analytics service, which underneath the hood uses MariaDB ColumnStore. And I've already preloaded data onto this cloud instance, which I'll kind of walk through what that looks like. But ultimately, what we want to do is show how we can capitalize on the fact that MariaDB's ColumnStore, or just columnar formatted data in general, on millions of records, allows you then to be able to utilize, more modern tools like Jupyter or maybe some other notebooks in combination with some visualization and some analysis libraries from Python with the MariaDB Python connector, which of course you could sub in any other kind of connectors. There's plenty of them out there in order to be able to communicate with different types of columnar storage as well. But we're going to take a look at this scenario just to take a look at, one, how we can utilize the data, right? How can we access MariaDB ColumnStore and then utilize columnar data. But we also want to take a look at how we do not have to add any indexes in order to be able to switch up the queries and in real time be able to analyze and then ultimately visualize that information as well. So I'm going to quickly jump into the demonstration. Let's pop over here into, and let's just make this a little bit larger. Hopefully it's large enough to see. Now, the information that I am going to be walking through pretty quickly here is all inside of some GitHub repositories that I popped into the chat. And it is a two-parter. One, I've already gone through the process of using this repository, which simply is a walkthrough of how you actually load information into MariaDB ColumnStore. It uses, the Bureau of Transportation provides millions of records dating back to like 1987. That allows you to look at domestic, US domestic travel statistics for, since 1987 until 2021. And it contains, millions of records. And I've loaded about 40 million records into the ColumnStore database so that we can go ahead and take a look at that. Now, I've done that using this repository, but I won't step through exactly all the scripts that I've added here that you can use to be able to do that. But what I do want to look at is the schema at a very high level. So just to get an idea, I have actually created just a single database, and it contains 3 tables. The database is called travel, and the idea here is that I'm looking at flight data, right? So I'm looking at those millions of records, the 40 million records of flight data. And I've added a couple of tables myself, like airlines, right? The domestic airlines, and then the airports, which contain different codes. And in the case of airports, contains the actual coordinates, or the actual coordinal directions, longitude, latitude of where those actual airports sit. Something that I can help to visualize as we get into it. And at the bottom here, you can see that I have a flights table. And this contains different things like the exact time that the flight took off, how long it was delayed, where is it going from? Where is it going to? Just a variety of different information. It's not necessarily so important to this demonstration, but just know that there's a lot of columns in here. Not a lot, but there's 30 or so columns in here. There's 40 million records. And again, this is going to be stored in a ColumnStore engine. So as we have the ability, as I indicated before, we can table by table be able to describe what engine we want to use. In this case, I'm just using ColumnStore, and I've loaded those records in there. So we're going to go ahead, and I'm going to load up a terminal window really quick here. Let's just pop this out of the way. Why that's not minimizing. Oh, there we go. I don't know. Who knows, right? Probably just clicked it wrong. And so we're going to pop into MariaDB, and I'm going to paste in a command here, because what this is going to allow me to do is take a look at connecting to MariaDB SkySQL. It's not necessarily important, this part of it, but more the data underneath, right? So I'm going to paste in a command, and I'm just using the MariaDB command line client, providing the information like the host address, the port number, the username, the password, and some security credentials or some security certificate stuff. This is going to let me connect to MariaDB SkySQL. And you can use the MariaDB command line client to connect to a local instance or maybe a containerized instance of MariaDB. Pretty much all works the same. You're just obviously the things that you put inside that command line, the arguments are going to change a little bit. But that's all indicated inside of that repository that I added to the chat. Now, from there, I just want to confirm that I've added my travel database. And then I'm just going to use my travel database. So I'm just going to step into it. And I want to show that I have created the airlines, airports, and flight table. Now, here, what I want to do is I want to just kind of like a magic trick, right? I want to show the indexes on the flights table, just to confirm that we don't have any indexes on this flight table at all. And that's going to allow us then to, as we start to look at, well, count isn't very interesting, but just to confirm that we've got, the 40 million records, 38 million records, and that was returned in about 0.2, 200 milliseconds, 250 milliseconds. But we can certainly get a little bit more in depth. So I'm just going to go ahead and start to paste, I think. I think I'm running a little bit shorter on time here. I'm going to start to paste this in here, and let's just show that here I can run, a very simple, as we were looking at an average before, a very simple aggregation query, where I am, let's see. Oh, yep, that will do it. And an equal sign there. And I'm just looking at, for 2019 specifically, I'm just looking at all of the delay information. And more specifically, I'm looking at the average departure delay. And we can see that it's about 10 minutes, it's 10 minutes, it's 10 minutes, almost 11 minutes is the average. And we can look, of course, kind of interesting, we can look at 2020 and we can see that there's a lot fewer flights. So of course, you can imagine that the departure delays are probably few and far between compared to 2019. But we can very easily take a look at this data. But that's not very interesting. What we want to do next is actually look at, I'm going to take a look at creating more of a visualization approach, combining the use of JupyterLab, a library called Pandas, which we can use for data analysis, Plotly for data visualization, and the MariaDB Python connector, which came out last year, in order to be able to connect to MariaDB SkySQL and ultimately the analytics data inside of it, in order to be able to visualize that in real time. Now, I've gone ahead and set up a virtual environment, actually installed JupyterLab with what it needs to be able to use things like Plotly, but that's just because it takes a couple of minutes. So to save time, I've gone ahead and set up that environment. But first, what I need to do is I need to activate my virtual environment, which is just going to allow me to step into the self-contained little ecosystem for Python. And then I want to just, I actually am going to cut to the chase here and install MariaDB, Plotly, and a library called Pandas. And those are libraries that I'm going to use for the example in order to be able to visualize the information. So the only thing that was really installed within this virtual environment is Jupyter. Now I'm just installing the libraries from the Python package index that are going to allow me then to connect to the database and then ultimately visualize that data. So once this is installed, then what I will do is I actually start up JupyterLab. And if this takes too long, I can always cut over to one that's already installed. There we go. And now, once they're installed, now I can just say Jupyter space lab, and that's going to allow me to just automatically pop up this notebook application. And if you're not familiar with JupyterLab, it's a pretty cool little tool that lets you be able to write, a variety of different languages on the fly. But what we're going to do is create a notebook for Python. And that's going to allow me then to be able to, write Python in real time. So like, for instance, if I wanted to say, test, and then be able to print that out. Of course, not very interesting, but it allows you, without having to create files individually and then execute, different things through an IDE or command line, you can just write it on the fly. So here, I'm going to, for the sake of time, paste some stuff in here. And I'll quickly explain what this means. So this is the usage of the MariaDB Python connector. So I very simply just import the MariaDB Python, which I just installed. I'm setting up some configuration to the database. So nothing new here. We're just looking at the host address, the port number, specifying username, password, that database travel, which I had created and preloaded. And then I'm setting up, the connection. I am then using a cursor object within Python in order to be able to execute a query. Again, just created on the fly here against a database with no indexes. And then I'm just fetching all that information and put it out. So here, I'll just execute, and we can see that, in pretty snappy time, we've returned what is just the count of, excuse me, the number of flights just based on year from 2015 to 21, just a short list here. Now, kind of ramping up what we can do, we can then just keep going and kind of scroll down here, and I can pop in a new chunk of code into a new cell inside of this, or a new note inside of this notebook. I now have added the ability to import Plotly. So I've added Plotly, which is a data visualization library. I've added pandas, which is going to allow me to use the Python connector from MariaDB and then put data into something called a data frame that I can then use to bind or map to the Plotly visualization. In this case, I'm going to be using a bar graph. So have that same configuration from MariaDB SkySQL. I am actually using the exact same query, right, where I'm looking at the number of flights per year. But now I want to look at it from a visualization or a bar graph perspective. Again, all of this being executed on a database with absolutely no query or no indexes, and just to see how fast it can return and then visualize this information. So from there, I'm grabbing the fetched information as I did before, and instead of printing it, I'm actually inputting it into a data frame, which is provided by pandas, and then I'm using that data frame then to be able to fill out or bind the information to the bar graph for Plotly. You can see here, whoops, there we go. That I'm just very simply able to do that. So we can see that, you know, for 2015, 16, 17 looked pretty similar. We started to go up in the number of flights for 2018, 2019. But then in 2020, of course, we had a little bit of a dip because of the pandemic for flights. And lastly, I want to take a look at the last demonstration, which is going to allow me to utilize, make sure I'm doing it right on time here, utilize even more, you know, or even more complex visualizations. Of course, they can get a lot more complex than this, but again, the information up front for being able to use the packages and, you know, connect to the database is mostly the same. But we're actually now going to take a look at a slightly more complex query where we're looking for the number of flights from airports. And then I want to be able to visualize that onto a map. And then I want to have that visualized in such a way that the more, you know, the more information or the more flights that we have, the larger the dot that pops onto this map, right? So it's pretty typical in how you can do that. I'm returning the data all the same way, right? So I'm using the MariaDB Python connector. I'm connecting to MariaDB analytics service. I haven't created any indexes for this, but I've started to change the type of information and the types of aggregation that I'm ultimately looking at, combining with other data, right? The longitude and latitude that exist inside of this database. And then I'm going to map that to a map box, a scatter box, basically. And so that's going to allow me to plot this information onto a map. And we can see just how fast we can do that by hitting execute. And just that quick, we were able to see that we took the flight information that again existed, you know, in the 40 million, 38 million records for MariaDB SkySQL, and then through the MariaDB connector Python or Python connector, be able to utilize both Plotly and pandas through Jupyter Labs. And that's just going to allow us then to map that out very easily. We have the ability to hover over in real time and quite literally look at the information that was returned to our query, and then just visualized through, you know, these mediums. But that is a very quick look at how you can get started with MariaDB ColumnStore in order to be able to utilize columnar-based format or columnar-based storage in order to be able to provide real-time analysis and then ultimately more data science types of activities using this type of format for storage. If you'd like to know more, let's see here. Oops, it's like if you'd like to know more, I'll just execute this really quick. About how you can do this. Again, I dropped those repositories. Oops, I dropped those repositories into the chat, so you can certainly utilize those and get started. It takes a couple of minutes on each one just to be able to jump in and get started. But if you'd like to know even more, we do have a developer hub where we have a bunch of open source and free pieces of content that you can jump into, such as tutorials, blog posts, videos, and dive even deeper into things like columnar storage or even data analysis. Today I did use MariaDB SkySQL. So if you'd like to get started checking out how you can use that, you can get started for free. Otherwise, I wouldn't put it up here with a $500 credit. So that's enough time to definitely run these examples and give it a go. You can also use everything I've done today locally on your machine, either installing it directly, or you can use a containerized version using Docker or something like that. So that's that's all there is for the demonstration today. I hope that you got a lot out of it. If you happen to have any questions now, you can ask me, or feel free to hit me up after as well.
All right. Hey, Rob, thank you for your presentation. It was wonderful. I know it's definitely difficult to get in both like a presentation, also a demo. You did a great job at kind of jamming it into 40 minutes with that.
Yeah, sorry about some of the quickness on some of that stuff. I can be a little verbose sometimes, so I'm like constantly telling myself, "Oh, I'll move along," because get excited and then kind of move through it quickly or as quickly as I can.
That's how passionate you are about it. So it's fantastic, So I'll make sure to thank you for the GitHub repositories you dropped into the chat. I'll make sure that everyone has access to that. And everyone, again, thank you for attending the presentation today. Once you guys are able to kind of get done, please take time to go through the survey and give us any hints, tips, or what you'd like to see next time for these sessions, right? Again, guys, thank you again for joining the session. And Rob, thank you for your presentation and the demo.
Thank you, Corey.
It's a great tool that everyone can find usable as soon as possible. So if you guys need anything else, feel free to let us know. But without that, guys, I enjoy the rest of today's DataCon LA 2021.
Thanks, Courtney. Thanks, everyone.
All right, take care.